brackets, we have here 1 plus I to the power n minus 1, or here we will have divided by I. Now this formula, it's equivalent to writing it this way: 1 plus r over m to the power mt minus 1, and here we could have r divided by m. So let's see if we can answer this problem. We have a business that sets up a sinking fund so that it will be able to pay off bonds that it has issued when they mature. Remember, when the term expires. If it deposits $12,000 at the end of each quarter, that's how we know we will use ordinary annuity, because it's at the end of the period. The account earns 5% interest compounded quarterly. How much will be in the sinking fund after 10 years? So it is clear that the question here is, what is the future value? When the payments will be of $12,000. And since we're talking about at the end of each quarter, it also says compounded quarterly. We know that M is 4, the number of compounding periods. The rate is 5.2, so it's 0.052. And for the time, we will use 10 for 10 years. So from here, we're going to enter everything in our formula. I'm going to be using the one that we have here. And so the future value will equal to bracket, parentheses here, 1 plus, parentheses again, 0.052 divided by 4, because it is quarterly. Then I have to close the parentheses again, because I want this whole thing to be raised to the power of m times t. So that will be 4 times 10 for 10 years. Then after that, I will need a minus 1. And then I will need to enclose my numerator. Remember, this parentheses here, actually, let's write it this way. And then this will be divided by 0.052 over 4. Close the parentheses, and then we will need a final one to close the bracket. Actually, I forgot to include the payment here, so that should be being multiplied by 12,000. So to enter this on the calculator, it will be 12,000 for the payment, and then triple parentheses, 1 for the bracket, 1 for the numerator, 1 for the stuff that is inside the parentheses that will be raised to a certain power. Here we can put our 0.052 divided by 4, but you have to close that fraction. And then here, after this will be, after you close this one in pink, that is closing with this one, you will enter the exponent, which is 4 times 10, or you could just simply enter 40. Then you need to move to the side with the right side arrow, and then minus 1. Then you will close your parentheses that will enclose the numerator. Then we enter the division key, and in parentheses we will enter the r over m, so 0.052 divided by 4. Close the parentheses, and then we have to close one more time, because that will be like if it was our bracket. That one closes this one here. So of course, if you enter everything correctly, you will get that the future value will be $624,370. that will be the future value of the sinking fund. And for that, we use the formula as the same as the ordinary annuity. Let's move on to example number 5. And so for number 5, we have here a firm borrows $6 million to build a small factory from the bank. The bank requires for the firm to set up a $200,000 sinking fund to replace the roof after 15 years. So the firm deposits a certain amount of money periodically, actually every year, compounded annually, on a 6% interest. So the question here is find the payment. So we're not looking for the future value, we're actually looking for the payment. The future value is going to be what the bank wants the firm to have after 15 years so they could be able to afford to replace the roof. So that will be the future value, $200,000. We also have the time will be 15. The interest will be, the interest rate will be 0.06. We're looking for the payment. And here M is 1 because it is compounded annually. So in this case, we could use the fact that N will be equal to MT. And so that will be equal to 1 times 15. So that gives us N is equal to 15. And for I, we will use R divided by M. And so that will be the rate 0.06 divided by 1, which is just 0.06. So we will use those numbers for N and for I. Now I'm going to rewrite the formula, and it's the same formula that we have here, but I'm going to rewrite it in these terms. So we have the future value is equal to the payment multiplied by 1 plus I raised to the power N minus 1, and then divided by I. Now we want to solve for the payment. That is the question. What is the payment? So since we're solving for the payment, we could take the whole thing inside the bracket across the other side. Since everything inside the bracket is multiplying to the payment, once we take it across the other side, it will be dividing. So it will be similar to having something like this, multiplying by the reciprocal. So what I'm going to do is I will be now on the top. And it makes sense because on the right side, it is dividing payment. So on the left side, it will be multiplying the future value. Now for this quantity here, on the right side is multiplying to the payment. So on the left side, it will be dividing the future value. And that is how we're going to solve for payment. So now we're going to make our substitutions. Keep in mind we're solving for payment. So we're going to need future value. We want that future value, or the bank wants that future value to be 200,000. And that will be, instead of I, we're going to enter 0.06. And on the bottom, we're going to have 1 plus 0.06 to the power, and I'm sorry, I'm missing a parenthesis here, to the power N. We established N was 15, and then minus 1. So if we enter all of that on the calculator, we will get the payment, and so that payment will be approximately $8,592 with 55 cents. So that is what the firm is supposed to put at the end of each year for a total of 15 years in order to have a total of $200,000 after the interest has been earned and after every single payment has been made. 8,592 with 55 cents. Now for this next example, example 6, we have, as an incentive for a value employee to remain on the job, a company plans to offer her a $100,000 bonus, which is pretty big, payable when she retires in 20 years. If the company deposits $200 a month into a sinking fund, because they're trying to save that amount so that they can afford to pay this person $100,000 after she retires, he or she. What interest rate must it earn the $200 payment a month in a sinking fund with monthly compounding? So now our question is, what will the rate be? In order to guarantee that the fund will be worth this much in 20 years. So we are looking for the rate. We know the payment is going to be $200. We know the future value should be $100,000, or at least $100,000, and we know that they have 20 years to complete that. So if we take the formula that we've been using for future value, it goes like this: payment, bracket, parentheses 1 plus I. By the way, here M is 12. So that will make N equal to 12 times 20. So N will be equal to 240. And for I, we're going to use R over M. And so for that, we will use R over 12. But since we're going to solve this by using our calculator, we will be using, instead of R, we will be use X, because we're going to graph it. So we're going to use X over 12, just a heads up. So then the formula goes like this, and then here we have I. So now let's replace what we know, and this will be the future value will equal to, well, actually we know what the future value is. We want that to be 100,000. We know the payment is 200. And here we're going to have 1 plus X over 12 instead of I to the power 240. I need to make some room here. Minus 1. And remember, this will have to have another parenthesis here for the denominator. And here we will enter X divided by 12. So what we're going to do is graph this one as one of the functions. Y sub 1 will be 100,000. And then this whole thing will be our other function, Y sub 2. So I have both of them graphed already. And this is not the 84, it's the TI Nspire. So we have the first one, the horizontal line, 100,000. And this is the other one, the one that will help us find what X is by finding the intersection point. So I'm going to go to my tools. You guys will go to calculate, and I'm going to go to analyze graph. You guys will go to calculate, and then I'm going to find the intersection between those two graphs. So for mine, I have to find the lower bound and the upper bound, the left and right side limits. And so I get that right here. So the X value is 0.067. Remember, we were using that to represent R. So we could say that as a percentage, this will be 6.7%, and that is the answer.